Hey everyone, so in this video I'm going to kind of tell you everything that's going to be on the Unit 4 test part 1. So this is the part that you do not get a calculator for. The first thing I'm going to do is kind of run through the topics and then I'll go into a couple of the problems. I'm not going to do every single problem, but I'm going to do enough to give you an idea of how to do them, and then I'm going to leave the rest for you to try and check your answer using the answer key. Keep in mind that the goal here is not that you get this 100% perfectly done, but you get it done and you understand what's going on. So don't treat it like a to do list or like a checklist, you've checked it off. Make sure you work through each problem and you're actually understanding what to do in each problem. So, there are a few things you need to know for this test. The first one is subtracting and adding polynomials. This is just like combining like terms. You need to know how to multiply them and maybe multiply and then add together. So a combination of the two. Then you need to know how to divide, sometimes with the box method and sometimes with synthetic division. So you need to know both types of division. You need to know how to sketch a polynomial graph if you get the factored form. So find the zeros, put them on a graph. And you also need to know how to identify the end behavior. One hint or kind of secret info I'm going to give you on this one is that the end behavior will be multiple choice on the test. So you won't have to write it out, but you will need to recognize which answer is correct. So you need to be comfortable with the formatting there. Then turning to the back side, you need to know how to factor. And when you're factoring, what I want you to do before you start anything is count the number of terms. Okay, because the number of terms tells you how to factor. If there are two terms, then the only way to factor that, at least for us, is going to be difference of squares. If there are three terms, then that is what's called a trinomial, which is where you are normally trying to find two things that multiply to the last and add to the middle. And if there are four things, you are going to use grouping. And I'm not going to give any other hints on that one right now because the word grouping in and of itself is a pretty big suggestion. Okay, and then coming down here, or keep going down, you will also need to be able to write the equation of a polynomial given the zeros. So here I have zeros for you. Here I tell you the degree, and I give you the limit or the end behavior. And then on 21, where it says write the standard form, I'm going to give you one suggestion here in case you don't want to watch the other examples. You're going to start with the factored form, then you're going to multiply it out. Okay? And then there's a little bit of matching here at the end. Again, this is really just focusing on the zeros of the polynomial graph. There are some things that I did not just talk about, and that is because the backside of 4.5, 4.7, 4.8, and 4.9 are going to be on the calculator portion, which is part 2. So if there's something you don't see on here, that's because it might be on the second half. So I'm going to come back to the front and kind of go through a couple of these. On number 1, you would multiply this 4 all the way through and this negative 6 all the way through, and then you're going to combine like terms. I'm going to go ahead and do this one instead, but that's an idea of how you would do number 1. So I've got this 2 here in the middle that I need to multiply to my parentheses. That's going to make 2x squared and negative 22. And then I'm going to add together my like terms. Keep in mind that like terms means you have the same exponent and the same variable. So x squared and 2x squared, and there's no x squareds over here. 2x squared plus another 1x squared, if you want to put a 1 there, makes 3x squared. And then I'm going to go on to my x's. I've got 3x here and 5x here. Together that makes 8x. And last but not least, my constants. I have negative 5 minus 22, which is negative 17, plus 13. Negative 17 plus 13, sorry, negative 27. Negative 5 plus negative 22 is negative 27, plus 13 is negative 14. And there you have it. Down here, we've got some that needs to be multiplied. My hint to you on number 3 is that when you square something, you're multiplying it by itself. So you need to write this as 5x plus 2 times itself, 5x plus 2. And then you're going to take this 5x and multiply it to both of these. And then you would take this 2 and multiply it to both of those. Okay, don't forget to combine like terms. Okay, CLT stands for combine like terms. And then on number 4, this is the one I'm going to do with you. You're going to multiply these two together. You're going to take this 2x times x and 2x times negative 5. That's going to make 2x squared and negative 10x, because 2 times negative 5 is negative 10. And then you're going to take the 3 and multiply it to both of those, which is going to make 3x and negative 15. Now, what we're going to do is combine our like terms together, including this up here. So I've got 2x squared and 1x squared, and that's going to give me 3x squared again. And then you've got negative 10x, 3x, and negative 4x. So negative 10 plus 3 is negative 7. Negative 7 plus negative 4 is negative 11x. And then you've got your constants. Negative 15 plus 9 is negative 6. One reason why I circle mine like this is because now I've made sure that all of these terms and all of these terms were included somewhere. So I didn't miss anything. All right, and then moving on to the division. One reason why you need both the box method and synthetic is synthetic only works if this is x and a number. It doesn't work if this is x squared or if it has a number in front of x. I'm going to do number 6, but number 5 works very, very, very similarly. So when you are using the box method, that is where you take whatever's on the bottom, x plus 2, and you're going to make a box out of it, where the x gets its own row and the 2 gets its own row. And I probably left a little more space up there, but that's all right. And then I'm going to draw my first column in the box. And inside the box, you're going to start putting the pieces of the polynomial on top. So 3x cubed. And basically what you're going to do is 3x cubed divided by x, which is just 3x squared. Or you're asking yourself, what do I multiply this by to get this? Well, it needs the 3 in front, and then to get from x to x cubed, you need an x squared. And then you multiply this the rest of the way down. So 3x squared times 2 is 6x squared. How the box works is every box inside has to be these two multiplied together, and these two multiplied together. Then, to move on to the next column, you need to check the diagonal. So we want this diagonal to equal 4x squared. And what you have to figure out is what do you put here so that these two add to 4x squared. 6 minus 2 is 4, so I need negative 2x squared right here. So that now they add up to what they're supposed to. Then I do the same thing I did over here to get the 3x squared. X times what is negative 2x squared? Well, you need the negative 2 in front, and then x times x makes x squared. And then negative 2x times 2 is negative 4x. And now to get our last column, we need to make sure that our x's add to the right thing. So this one is supposed to equal 7x. Okay, this 4x squared is coming from the top, the 7x is coming from the top. And we need to figure out what do you add to negative 4 to get to 7? Well, you're going to add 4 to get to 0, and then 7 more to get up to 7. 4 and 7 makes 11. And then that means that x times 11 is 11x, and 11 times 2 is 22. If this number right here is the same as this number right here, your remainder is 0. And your answer is right here. 3x squared minus 2x plus 11. And coming over here to do synthetic. This one's a little bit faster, but you do have to remember how to do it because it's less natural. So you're going to take the 0 or the root and put it in a box right here. So, of the denominator, sorry, I should have said that before. So the denominator is the bottom part. The root to this part would be if x plus 2 were to equal 0, then you would subtract the 2 to the other side, and x would be negative 2. So it's always going to be the opposite. And then you put your coefficients. So 3, 4, 7, 22. And then you're going to drop this 3 down. Okay, so you draw this line underneath, leaving space for a new row right here. The first number comes down, and you're going to take this number and multiply it by whatever is in the box. 3 times negative 2 is negative 6. You write that in the next column, and then you add these together. Negative 2. And then you take your new number and multiply it by the one in the box. Negative 2 times negative 2 is 4. Add those together, that's 11. Take that and multiply it over here, that's negative 22. Add those together, that's 0. That is your remainder. And then to turn this back into a polynomial, this is your constant, and you go up a power of x as you move to the left. So this would be just x, the next one would be x squared, the next one would be x cubed, and continuing on. So we get the same answer as we did with the box method. Okay, a couple people have always asked me why, now that we're kind of reviewing these two together, the reason why you multiply this times this is because this is just really the number that was over here, but the opposite, and this is kind of your answer from up here. So they did get multiplied together here, and then we added these two together to get the next piece. So that's really what's going on there. It's kind of like taking away all the extra pieces of the box method. Okay. 4.5. What you're going to do is use the parentheses to find your zeros. And you're going to put those zeros on a graph that has an x and a y-axis, kind of like this. I'm going to add 5 for right now. Okay, in order to find those zeros, you're only worried about something that has an x. So for example, this one doesn't have an x with it. In fact, all that that -2 does is mean that the right side goes down. Okay. If there wasn't a negative, if this was just 2, then it would go up. And then your first set of zeros is going to come out of here. So this is an x squared. Remember that you're setting it equal to 0 to find the zeros. So you would add 16 to the other side. And then you need to get rid of the squared because you don't want to know what x squared is. You want to know what x is. And whenever you do the square root, remember that you have to have a plus and minus. And then the square root of 16 is actually 4. So I'm going to come over here and put a point at 2, 3, 4, and -4. And then this one, if you did x plus 3 equals 0, you would get -3 as your answer, because you would subtract 3 to the other side. So those are your zeros of this graph. Then we already said that the right side would go down because of that negative. So go to whichever zero is the furthest to the right and draw an arrow going down. None of these are double roots. They're all going to go right through. So right through this one, right through this one, right through this one. Gets a little awkward there at the end because they're so close together. And then I'm going to list the end behavior down here, down below. There are 2 ends to each graph. We're going to write lim for limit, and x goes to infinity underneath, x arrow infinity. We're going to figure out what that one is, and we're going to do lim, or the limit, as x goes to negative infinity. This is just a fancy way of saying the right side. This is just a fancy way of saying the left side. Because as x goes to infinity, you're going this way. And as x goes to negative infinity, you're going this way. And then on the other side of the equal sign, you say whether it's going up or down. So on the right side, this graph is going down. That would be negative infinity. On the left side, this graph is going up. So that would be positive infinity. All right, keep in mind that anytime it has a little 2 outside like this, that means it is a double root, and instead of going all the way through, it is going to bounce. Let's talk about factoring. So I'm actually going to solve numbers 13, 11, and 12. I am picking one that has 3 things, one that has 2 things, and one that has 4 things. And the directions here say solve each polynomial by factoring, sketch a graph on 10 through 15. So I am going to sketch the graph for you. This is just more practice of what we just did. It should not be that difficult of a thing to add the graph. If it is, talk to me because it's a lot easier than you're making it. So on 13, before I start, I see that these numbers are a little high, like I've got 120. What that means is there's probably a number that goes into all of these, and that number happens to be 4. So I'm going to take a 4 out, meaning I'm going to divide them all by 4. And they all have an x, and actually they all have an exponent of at least 2. So I'm going to put 4x squared in front and divide all of the numbers in front by 4. So that's 1, 7, and -30. And then because I put the x squared here, that takes a power of 2 away from these. So this one's just gone. It's just the number. This one's just going to be x, and this one's going to be x squared. Now, you have 3 terms, so you are looking for the 2 numbers that multiply to -30 and add to 7. And you're going to put those in parentheses with x like this. Okay, and I'm going to write -30 over here. and negative 5 and 6. Okay, so I want them to add to 7. So it's not negative 1 and 30 or negative 2 and 15. There we go. Negative 3 plus 10 is 7. Okay, and then you're going to list your zeros. So you want to actually solve the polynomial. This would be just factoring. And I will ask you to do some of this on the test, but to save us a little time, I went ahead and had you solve these all the way through. This one is going to have a 0 at 0, and since it's squared, that's a double. This one is going to be at positive 3, and this one is going to be at negative 10. Because again, you're trying to make it equal 0. If you want x squared to equal 0, x has to be 0. If you want x minus 3 to equal 0, x has to be 3, because 3 minus 3 is 0. And then same thing here, negative 10 plus 10 would be 0. So what I need now is to put these zeros on a graph. And I'm not going to write all my tick marks out. I'm just going to put 3 and negative 10. And then I'm going to put dots there at 0 and on the negative 10. And I'm going to double check before I draw my graph that I've found 4 zeros because that's my highest exponent. This counts as 2, 3, 4. So I do have my 4 zeros. Since this 4 is positive, not negative, go to the one on the right, it should go up. 3 is not a double root, so it's going to go all the way through and up to 0. 0 is the double root, so instead of going all the way through like this, it's going to come back down. And then it's going to go all the way through negative 10 because it is not a double. Like that. On number 11, there are only 2 things. There is no number that goes into 4 and 25, so we're going to go straight to factoring, difference of squares. This is the one where you have a plus and a minus, and the things that go inside the parentheses are the square roots. That's why it has to be a square. So the square root of 4x squared is 2x, and the square root of 25 is 5. Okay, the easiest way to remember this is that there's no x's in the middle, and the only way for the x's in the middle to cancel is if you had the same thing but opposite sign in the middle. These are called conjugates. And then on number 12, there are no numbers that go in all of these because this one doesn't even have a number. And there isn't an x on all of them. There is an x on the first 3, so it looks like there might be one on all of them, but then the 28 doesn't have one. So we are going to go straight to grouping because there are 4 things here. So we've got those 2. I can divide both of those by x squared without making any fractions or decimals. And then that leaves me with x minus 7. And over here, I can divide these both by negative 4. And that leaves me with negative 4x divided by negative 4 is just x. 28 divided by negative 4 is negative 7. And when you are factoring by grouping, you should find out that these two match. That is your first parentheses. And then you have the x squared minus 4, which comes from the outsides. Okay, now I'm going to go ahead and finish up these last 2. Over here, this one would be negative 5, and then you have to divide by the number in front of x. Okay, if you were solving the equation this equals 0, you would subtract the 5 and then divide by 2, which is why it's negative 5 divided by 2. On this one, you would add the 5 and divide by 2, so that would be positive 5/2. Okay, that's only 2 zeros because guess what? It was only x squared. So I've got negative 5/2 and 5/2. And my 2 zeros there. Since this 4 in front is not negative, it's going to go up. And it's going to cross through and cross through because neither of them are are double zeros. Over here, be careful. This one is going to become 7 because you would add 7 to the 0. And this one would be x squared equals 4. So you're going to have to do that square root of 4, which is plus minus, because we're doing a square root. And then the square root of 4 is 2. So that's going to leave you with -2, 2, and 7. Those are your 3 zeros because our equation started off with x to the third. Since there's no negative right here in front, it's going to go up on the right side. None of these are doubles, so it's going to go all the way through. Like so. Now you might be like, but this one was squared. It was squared on the inside, which gave us 2 answers. So it's not a double, but this one parentheses produced 2 and -2. All right, and then I'm going to come down here to 20 and do one of these with you. This one just wants you to sketch an odd degree. Pick your own. Give it 3 or 5 or 7 zeros. And a positive leading coefficient means it goes up on the right. On 20, you are going to write the factored form. That means with parentheses. I am going to choose B because it's a little trickier. So I'm going to start with y equals because it wants an equation. Cubic means that we're going to have 3 sets of parentheses. And guess what? It doesn't tell you what the zeros are, so you get to make up your own. So I'm going to go 1, 2, 3. You could also, if you wanted to, just say, oh, I want this one to be a double, and this one. That's technically 3 zeros as well. So there's unlimited options here. But then it says the end behavior as x goes to infinity, so this is on the right, it goes to negative infinity. So if the right side is going down, then that means that you need a negative right here. Okay. And then on 21, it wants you to write the standard form. And I had told you before, you're going to start with factored form and multiply it out. I'm going to go ahead and do the 4th degree one because it's a little trickier. If you have a 0 at 0, that means you have an x in front. And since it's a double, it's squared. Then 2 means it was x minus 2 in the parentheses. So it's always going to be the opposite in the parentheses that it is as the 0, which means that -5 is going to turn into x plus 5. And then what you need to do is multiply all of this together. So I need to multiply these two first, and then I'm going to multiply by x squared afterwards. Okay, so x times x is x squared. X times 5 is 5x. -2 times x is -2x. And -2 times 5 is -10. And then take that x squared in front and multiply it to everything. It's basically just going to add a power of 2 to all of them. And I made a slight mistake, and that is I forgot to add these two together in the middle first. So I ended up with 2x cubes. That's fine, I can just do it from here. 5 minus 2 is 3x to the third minus 10x squared. Okay, so when it says standard form, it wants you to go ahead and multiply it all the way out.